and hi everyone. This is the second part of subtopic 1.4. In this in part 2 video, okay, I will explain about the equations of planes. All right. So let's take a look at this figure. All right. This is our plane P. Okay. This is the plane. And previously in equation of line, we need to have a parallel vector v, but in the case of equation of plane, we need to find the normal vector n. Okay, so this is the normal vector. All right, now let's say we have a point P and P naught on the lies on the plane, okay, and we have the parallel vector. This is the parallel vector. This is the vector that parallel to the plane, okay guys. So in order to find the equation of the plane, we need to have the point P naught and also the normal vector or perpendicular vector. Okay, some books call this as orthogonal or perpendicular. Okay, so this is the formula. N dot product with R minus R naught, okay guys, equals to 0, because the concept of perpendicular vector, perpendicular dot product with parallel vector, we get 0. So we have N dot product with R minus R naught. So N, the element of normal vector, is A, B and C. Okay, A, B and C. Dot product with R minus R naught. R, the element of R is X, Y and Z, and element of R naught is Y, X naught, Y naught and Z naught. So we have this equation. Alright. Alternatively, we can write the equation of plane like this. Okay, ax plus by plus cz plus d equals to 0, where d is negative of summation ax naught plus by naught plus cz naught. Okay, now, okay, let's take a look at example 7. Find an equation of the plane passing through the point 9, negative 1, 3 and orthogonal to the vector n, negative 6, 2, 4. Okay, so let's take out the informations given. In this case, we have P naught as 9, negative 1, 3 and the normal vector is negative 6, 2 and 4. Okay. So I will show the answer by using alternative method. Alright. Now this is X naught, Y naught and Z naught, and this is A, B and C. Okay. So the formula of equation for the plane of a plane is like this. Ax plus by plus cz plus d. Okay, so in this case we need to calculate, okay, where d is actually negative of ax naught plus by naught plus cz naught. Okay guys, so now let us substitute all the values into the formula. Thus the equation of the plane is ax plus by plus cz plus d. So a is negative 6, x plus b is 2, so 2y, and z is and c is 4, so plus 4z plus d equals to 0. Okay, so I miss here. So now let us calculate the values of d. D equals to negative of ax naught, so a is negative 6 times x naught, 9, plus 2 times negative 1 plus 4 times 3. So we have the values of d is equivalent to we have 12, so 44. Negative 54 minus 2 is negative 56, 12. So yes, negative and negative, so becomes positive 44. All right. So therefore, the equation of the plane is negative 6x plus 2y plus 4z plus 44 equals to 0. Okay. Now we also can have negative 6x plus 2y plus 4z equals to negative 44. Either one, both are correct. Okay, next, the question asks to sketch the plane. Okay, in order to sketch the plane, let us by using the intersect form, we can divide everything by negative 44. So make sure the values on the right hand side equivalent to 1. So divide everything by negative 44. Sorry. Negative 6x divide negative 44 plus 2y divide negative 44 plus 4z divide negative 44 equals to 1. So we will have x negative becomes positive. We have 3x over 22 plus y over 22, and then plus z over negative 11. Sorry, right here should be, this is negative, and it's nice if I put like this, negative 22 equals to 1. Okay, because there's the negative symbol right there. So basically I also can rewrite these equations into x over 22 over 3, and then y 22, and this should be 11, right? Minus sec over 11 equals to 1. So let us sketch the graph. This is x-axis, y and z-axis. X is positive, so we have x equals to 22 over 3, and then the values of y equals to negative 22, and then z equals to negative 11. So we will have this plane. Okay, let I color this. Okay, that's it. So that's the plane for this question. Done. Next question, for example 8. Find an equation of the plane through the points P, Q, and R. Okay. So we have 3 coordinates here. As I mentioned earlier, in order to form equation of plane, we need 2 informations. We need to have P naught and we also need to have the normal vector. But in this example, we don't have the normal vector. So what we should do here is we need to find the normal vector first. Okay. So how do we find the normal vector? Is by using the cross product of V1 cross V2. Okay, what is V1 actually? V1 is a vector, parallel vector from P to Q. So as usual, the vector of Q minus the vector for P. Then we have -5, 1, 0 minus 2, -7, 4. So we will have -5 minus 2, we get -7. 1 minus -7 should be 8. 0 minus 4, -4. Okay. So now we need to find the second vector, parallel vector. Is from P to R. So we have R minus P. So R is 3, 8, -1 minus the vector for P should be 2, -7 and 4. So we have 3 minus 2 should be 1, 8 minus -7, 15. And then -1 minus 4, -5. Okay. Now let us do the cross product. Normal vector equals to V1 cross product with V2. So we have to do like this. I, J, and K. And don't forget we need to put plus minus alternately for each direction. So for the first row we have V1. So V1 is -7, 8, -4, and the second normal vector is 1, 15, -5. Okay. So let us solve this one by one. Close the first column. So we are crossing the second and third column. So 8 times -5 minus 15 times -4. Okay, so we have 15 times -4. That is for I component. Now we continue for the J component. Since we have negative besides the J, so we need to put minus here. Open the square bracket. Right now we close the second column and we are crossing the first and third column. So we have -7 multiplied by -5 minus 1 times -4. This is for J. Okay, let me add some page. And then plus for K direction, close the third column. So we have -7 multiplied by 15 minus 1 multiplied by 8. This is for K direction. Right now we need to solve all of this. So we have -40 plus 60i minus 35 plus 4j, and then plus we have negative 105 minus 8k, right? So altogether we have negative 40, so 20i minus 39j, and then minus 5 plus 8, so negative 113k. Alright. In other way, we can write normal vector as 20, negative 39, negative 113. That's it. Okay, so now this is our A, B, and C. Alright. We can choose P naught as P. So we have P naught equivalent as 2, negative 7, 4. Okay, so 2, negative 7, 4. Alright. So this is our X naught, Y naught, and Z naught. Okay, so let's just substitute into the formula or equation of plane. Thus, we can have AX, so 20x, plus BY, so minus 39y, plus CZ, so minus 113z, plus D equals to 0. So we need to calculate D, negative AX naught, so 20 multiplied by 2, plus negative 39 multiplied by negative 7, plus negative 113 multiplied by 4. Alright, so we will have D equals to, this is negative 40, minus become positive 273, and this is minus 452. Okay, so we will have negative of, this one should be negative 139. So the answer is positive 139. Therefore, the equation of the plane is, we will have 20x minus 39y minus 113z plus 139 equals to 0. This is the answer. Okay, so now in order to sketch the plane, just the same step as previous example, what we should do is we have to rearrange the equation. So we use, again, by using the intercept form. Okay, first we need to rearrange this equation. So we have 20x minus 39y minus 113z equals to 139 negative. So divide everything by negative 139. We have negative x over 139 over 20 minus become plus, y equals to 139 over 39, and then plus z over 139 over 113 equals to 1. Okay, so negative become positive. So now let us sketch the axis. Okay, we have x-axis, y, and z. So x is negative. So negative, we need to have the coordinate at the back. So we have here negative 139 over 20, and then y is positive, so we have this 139 over 39 And then we have coordinate z equals to 139 over 113. Therefore, this is the plane in this question. Okay, that's it. So next, parallel test. All right. So we will have three conditions or three situations for parallelity. Okay, the first case is for line versus line. Alright, and this is the formula. In order to determine whether the two lines are parallel, we need to find a values of k such that v1 equivalent to kv2. K is any constant. And then plane. Alright, so to test whether the plane 1 and plane 2 are parallel, we need to find the normal vector, of course, and then we need to show that n1 is equivalent to kn2. Alright, and then in order to test whether the line and plane are parallel, we need to use the dot product. Okay, and then dot product of v dot n must be equals to 0. If we don't get 0, then the line and plane is not parallel, so it should be intersect. Okay, example 9. Test whether two lines are parallel. This example is similar to example 1.4.3.3 in our module. Okay, I just changed the values here. So now what we should do is test whether two planes. Okay, so we need to use the second formula here. First of all, we need to identify what is n1. So let us consider this as the first plane. So we have n1 equals to 6, negative 3, and then 12, and then n2 from the second plane. We have negative 2, 1, and negative 4. So we need to show that n1 is equivalent to kn2. So in this case, is there any values such that 6 equals to k multiplied by negative 2? Alright, so let us look at one by one item here. So 6 is actually 3 times negative 2, right? So we have a coefficient for negative 2 times 3. Alright, now 1 times 3, negative 3, we get negative 3. Negative 4 times negative 3, we get 12. So yes, we can say that n1 is equivalent to negative 3 and 2, right? So yes, since we can find the values of k is negative 3 in this case, yes, both planes are parallel. Okay. Example 10, we need to test whether the line and plane are parallel. And in this case, it stated that the line and plane are not parallel. Okay. And then we need to find the point of intersection between the line and plane. What we should do here is, first, we have to show that the line and plane is not parallel. Okay, so we need to find first what is n. In this case, okay, let us find v first. V is negative 8, 3, 1. V is taken from the line. Okay, remember parallel vector must be related to the line. And n is taken from the equation of plane. So we have n equals to 1, 2, and 3. Alright, now, in order to test whether the line and plane are parallel, we need to show that v dot n must be equals to 0. So, of course, in this example, v dot n must not be equals to 0 because the question asks you to show the line and parallel are not line and plane are not parallel. So let us do the dot product. V dot n equals to negative 8 multiplied by 1 plus 3 times 2 plus 1 times 3. So we have negative 8 plus 6 plus 3. This is equals to 1. Okay. Now, since v dot n is not equals to 0, thus the line and plane are not parallel. Okay, so next we need to find the intersection point between the line and the plane. So we have in order to find the intersection point, what we should do is we need to substitute equation of line into the equation of plane. Alright, so substitute the equation of line into the equation of plane. Okay, so we have line into plane. So x equals to 1 minus 8t. So we have x plus 2y plus 3z equals to 10. Okay, x. Right. So 1 minus 8t plus 2y. So 2y is 2 plus 3t. So 2 plus 3t, and then z equals to 3z. So multiply by 3, and z is 5 plus t. Equate this with 10. So we have 1 minus 8t plus 4 plus 6t plus 15 plus 3t equals to 10. Okay, nice. So negative 8 plus 60, we have negative 2 plus 3t should be t equals to 1 plus 4 is 5 plus 15 should be 20. So 10 minus 20 is negative 10. That's it. Okay, so this is the values of t. Now we need to resubstitute the values of t into the parametric equations of line. So we have x equals to 1 minus 8t. So t is negative 10. Then we have negative 8 times 10, 81. And then y equals to 2 plus 3t. So 2 plus 3 times t, negative 10. So we have negative 28. And then z equals to 5 plus 3 times negative 10. So, sorry, there are no 5 plus t. Okay, so 5 plus negative 10, we get negative 5. Therefore, the point of intersection is 81, negative 28, and negative 5. Done. That's it. Okay, example 11. Find an equation of the intersection line between the planes. Okay, between the planes, we have two planes here. Alright, now let's say consider this as plane 1 and this is as plane 2. So we have n1 equals to 2, 1, negative 3, and n2 equals to 4, negative 1, and 3. Okay, in order to find the equation of line, okay guys, this is the line. Okay, this is the line that intersect between the first plane and second plane. Okay, so here is the intersection line. Okay, in the first part of my video, I already explained to you that in order to form equation of line, we need to have two things, right? P0 and V, normal vector. So now we need to find our V. In this case, calculating V means we do the dot product, sorry, the cross product of n1 and n2. So we have I, J, and K. And again, we need to put plus, minus, plus alternately. The first row should be the n1. So we have 2, 1, negative 3. And the second row is 4, negative 1, and 3. So let us solve this one. The first step, close the first column. So we are crossing the second and third column. So we have 1 multiplied by 3 minus negative 1 multiplied by negative 3. This is for I. And for J, don't forget to put negative. So we have minus. Close the second column. So you are crossing the first and third column. So we have 2 multiplied by 3 minus 4 multiplied by negative 3. This is for J, and for K, close the third column. So we have 2 times negative 1 minus 4 times 1. This is for K. So we will have, let us solve this one. Negative 3, negative becomes positive. So 3 minus 3 becomes 0. Yes, 0i. And then 6 minus, so plus 12. 6 plus 12 should be 18. So we have negative 18j. And then for k direction, negative 2 minus 4 is negative 6k. Sorry. Negative 6k. So we have thus V is 0, negative 18, and negative 6. Alright. Now, we need to find the P0. Okay, so how do we find the P0? We need to choose whether the line intersect to xz plane, yz plane, or xy plane. Okay, let me write something here. We need to find a point on the line. Okay, let us choose a point on L that intersect xy plane. So xy planes means z equals to 0. Okay, I will highlight this. Z equals to 0. So okay, xy plane. So now when if we substitute z equals to 0 into the equations, equation of plane of both planes actually, sorry. We will get, where is the equation? Okay, let's say we have z equals to 0, so 2x plus y equals to 4. And then we have 4x minus y equals to 5. Alright, so let us solve. This is 1 and this is 2. Okay, so we need to solve this equation simultaneously. So since we have y and negative y, equation 1 plus equation 2, we will get 0y, right? So we have equation 1 plus equation 2. Yields 2x plus 4x is 6x, y plus negative y, we get 0. 4 plus 5 equals to 9. So x equals to 9 over 6, which is equivalent to 3 over 2. Yes, okay. Thus, if we substitute into the first equation, we can get y equals to 4 minus 2x. So 4 minus 2 times 3 over 2. We will get y equals to 1. Okay, so therefore we have x equals to 3 over 2, y equals to 1, and z just now is 0, right? So z equals to 0 is actually a point that lies on L. Okay, that lies on the line L. So P naught 3 over 2, 1 and 0, and then the normal vector just now is the parallel vector 0, negative 18, negative 6, right? 0, negative 18, negative 6. Okay, so now this is our x naught, y naught, and z naught, and this is a, b, and c. Therefore we will have the equation of line is x equals to x naught plus at. X naught is 3 over 2. But a is 0, so we don't have just x equals to 3 over 2. And then y equals to x naught plus bt, so 1 minus 18t. And then z equals to 0, so 0 plus 6, negative 60, so we have negative 60. That's it. These are the answer. Okay, next, intersecting planes. So let's say we have two planes that intersect to each other. Let's say I sketch It's like this. Let's say this is the first plane and this is the second plane, P2. So we will have an angle here. This is the angle, okay, between the two planes. Alright, so this is the formula in order to calculate the angle, the acute angle between the two planes. We have cos theta equals to magnitude modulus of n1 dot n2 dot product n1 and n2 divides by the magnitude of n1 multiplied by the magnitude of n2. Okay, the modulus. Alright, so now let's take a look at example 12. So let's take out the informations given. We have n1 equals to 3, -2, and 5. And then n2 equals to 2, -1, and -4. Okay. First, we need to find the dot product. So n1 dot n2 is equals to 3 times 2 plus -2 times -1 and then plus 5 times -4. So we have 6 plus 2 is 8 minus 20, -12. Next, we need to, take the modulus of n1 dot n2. It becomes 12. Okay, now we need to find the magnitude of n1. Means square root of 3 squared plus -2 squared plus 5 squared. So this is equals to 9 plus 4, 13, 13 plus 25, we get square root of 38. And then magnitude of n2 is square root of 2 squared plus -1 squared plus -4 squared. We will get 21. Okay, so therefore, since the formula is cos theta, modulus of n1 dot n2 divides by magnitude of n1 multiplied by magnitude of n2. Thus, cos theta is equals to 12 divided by square root 38 multiplied by square root 21. So theta, you can use your calculator. So change your calculator to degree mode. So shift cos, arc cos, 12 divides by square root 38 multiplied by square root 21. So the answer is 64.862 degrees. Okay, done. That's it. Alright, distance between two planes. This is the formula to calculate distance. Okay, two planes means we have P1, plane 1 and plane 2. Alright, so if you consider the P0 from the first plane, so you must consider the normal vector from second plane. Okay, you cannot use P0 and normal vector on the same plane. It should be different. So only then we can form this. We can find the distance between the two planes. Okay, so example 13 is very direct example. Find the distance. You are given the P0, -1, 7, and 4. And then the normal vector is taken from the equation of the plane. We have 2, 3, and -1. So now, Alright, the formula distance equals to modulus of ax naught plus by naught plus cz naught plus d divides by a squared plus b squared plus c squared. Alright, in this example, this is our x naught, y naught and z naught, and this is a, b and c. Okay, so just substitute into the formula. Okay, oh, before I forgot, d in this case is negative 5 because we change the position here. So it becomes negative 5. So let us substitute all the values into this formula. We have negative 1 multiplied by 2 plus 7 multiplied by 3 plus 4 multiplied by negative 1 plus negative 5 divides by square root of 2 squared plus 3 squared plus negative 1 squared. So we will have negative 2 plus 21 should be 19. 19 minus 4 is 15. 15 minus 5 should be 10. So we have 10 over square root of 14. That's it. Next, find the distance between the parallel planes. Okay guys, now let's say we have plane 1, 2x plus 3y minus z equals to 5, and the second plane, plane 2, 4x plus 6y minus 2z equals to 3. So now, let's say we consider the normal vector from plane 1. Let us take the normal vector from plane 1. Okay, so we have n equals to 2, 3 and negative 1. And in this case, d is equals to negative 5. Okay, so now since we already take the normal vector from plane 1, now we need to consider point P naught from the second plane on the plane 2. So how do we find the coordinate? Alright, we need to sketch the plane 2. Okay, so plane 2 is 4x plus 6y minus 2z equals to 3. So again, by using the intercept form, we divide everything by 3. We have 4x over 3 plus 6y over 3 minus 2z over 3 equals to 1. So we can write x over 3 over 4 plus 2y. Let me erase this first. 4x over 3 plus 2y minus 2z over 3, so equals to 1. So we can rewrite this as x over 3 over 4 plus y over 1 over 2 minus z over 3 over 2. Okay, equals to 1. So the plane should be looks like this. Okay, we have x, y, and z. So x is 3 over 4. Let's say here is 3 over 4. And then y equals to 1 over 2. And then z equals to negative 3 over 2. So this is the plane. Okay. Alright. So now, in this case, we have 3 coordinates. Okay. The coordinate here is 3 over 4, 0, 0. And the coordinate here is z. So we have 0, 0, negative 3 over 2. And the coordinate here is 0, 1 over 2, 0. Right? Because it depends on the x-axis, y-axis, or z-axis. Okay. So therefore, we can choose either one of these coordinates. Okay. So we can take either either 3 over 4, 0, 0, 0, 1 over 2, 0, or 0, 0, negative 3 over 2 as P naught. Let us choose 3 over 4, 0, 0 as P naught. Don't worry, if you choose 0, 1 over 2, 0 or 0, 0, negative 3 over 2, you still get the same answer, okay? Because the distance between the first plane and the second plane should be the same, no matter which point did you take to calculate the distance. Okay, so we have this. Since n is equals to 2, 3, and negative 1. And just now we have distance, d equals to negative 5. Thus, the distance is we have, okay, this is x naught, y naught, and z naught, and this is your a, b, and c, and this is of course d lah. So we have distance 3 over 4 multiplied by 2 plus ax naught plus by naught, 3 times 0 plus negative 1 times 0 plus minus 5 plus d, right? So divides by square root of 2 squared plus 3 squared plus negative 1 squared. So the answer would be negative 3 over 4 times 2 should be 3 over 2 minus 5 is negative 7 over 2 square root of 14. Okay. So the answer will be seven over 2 times square root 14. Or you can put your answer into decimal places, 0.9354. 0.9354. Okay. So that's it. That's all for today. Thank you very much.